You may recall that we found the LCD of 1/8 and 3/22 to be 88. The denominator, the lowest common denominator of 8 and 22 was the 88. And so if we want to combine these fractions eventually, we have to write them as equivalent fractions using 88 as the denominator. How do we make 1/8 into something over 88? So what we do is we divide this denominator into 88 and then multiply it by the top. So in other words, 8 will go into 88 how many times? 11 times. And 11 times 1 gives me 11. So my numerator will be 11. So in other words, 1/8 is the equivalent to 11/88. Similarly, 22 goes into 88 4 times, and 4 times 3 is 12. So my numerator would be 12. So now we have two fractions that have the same denominator, and we can now add or subtract them. Now, how does this work for rational expressions? So here we have a rational expression that we want to convert to an equivalent fraction of something over 27a squared b. So we want 4b over 9a to be equal to something over 27a squared b. So what should we do? Well, just as we did in the fractions, we divided this denominator into this denominator. Somewhere on your scratch paper you may be looking at 27a squared b divided by, because we're dividing this into 9a. And if you've done that, you might say, okay, 27 and 9, that gives me a 3. A squared over a, that gives me an a, and then a b. So in other words, 9a goes into this denominator 3ab times. And so what we do is we multiply the top by 3ab. So another way of looking at that is just simply multiply the entire fraction by that number you have found, or by that expression, or term, 3ab over 3ab. And the reason we do this is because we're just multiplying by 1. But what we have done now is 9a times 3ab gives me the 27a squared b, and 4b times 3ab will give me, well, that's 12a b squared. And so we have an equivalent fraction. Just note that what we have done is multiplied by 1, but we've made that 1 by looking at how many times this denominator goes into this denominator, which will be, as we add rational expressions, that will be our LCD eventually. Let's take some more examples. Okay, here we have an expression, 3 over x squared minus 5, and we want to write it as an equivalent fraction, something over 3 times x minus 5 times x plus 5 times x minus 3. So again, we have to see how many times that this denominator will go into this denominator, and that will be what we multiply by. You may notice that x minus 5 times x plus 5, this is actually, if we did the product of these two, this is x squared minus 5. So our denominator is actually 3 times x squared minus 5 times x minus 3. And if you notice, therefore, this denominator goes into this denominator, whatever's left over, 3 times x minus 3. In other words, on your scratch paper, you're doing something like this. You're doing this division, and you're seeing that these two cancel, so we get 3 times x minus 3. So 3 times x minus 3 is what we want to multiply both top and bottom of our expression by. So let's do that. So we have our 3 over x squared minus 3, and we're going to multiply both top and bottom by this 3 times x minus 3. And if we do that, on the bottom, note what we get. We're going to get x squared minus 5. We're going to have a 3, and x squared minus 5, which I will break apart just so that we see it's the same as x plus 5, x minus 5. X minus 5, x plus 5 is x squared minus 5. And then we'll have an x minus 3. So remember, we're just multiplying these polynomials, right? And just multiply straight across. But the top now will be what? The top will become 9. 3 times 3 is 9 times x minus 3. You don't want to simplify this. This is in preparation to adding and subtracting fraction. You might be tempted to do that, but we'll come back with what we started with. But remember, we want to create it like this in order so that we can add and subtract fractions. So this is an intermediate step into doing that. So let's take another example where we have two rational expressions, unlike denominators, and we want to use the LCD to make equivalent fractions. Okay, here we have two fractions, 17x over 4y to the fifth, two rational expressions, and 2 over 8y, and we want to write them as equivalent fractions using a denominator that actually I haven't given yet. That denominator, first of all, we need to find, and we're going to find the LCD. So what will be the LCD of these two rational expressions? We notice we have 4 and 8. So 8 is actually the bigger number that 4 will divide into. So 8 is going to be here. And then we have y, but we have a y here and a y fifth here. So we take the higher power, so we're going to have y fifth here. So LCD is 8y to the fifth. Now we want to write these rational expressions as equivalent fractions using 8y to the fifth as the denominator. And let's take the top one. What should we multiply by to get 8y fifth? Well, we can see here, if I just multiply by 2, I get 8y fifth on the bottom. So all we need to do with this one is multiply by 2 over 2. And so 4y fifth times 2 gives me the 8y fifth, and 17x times 2 gives me 34x. Similarly, on the second one, what do we multiply 8y by to get 8y to the fifth? Well, we need 4 more. We need y to the fourth on that bottom to get a y to the fifth here. So therefore, we multiply this expression by y to the fourth over y to the fourth. And that will give me the 8y fifth on the bottom. And on the top, we'll get 2y to the fourth. Now we have two rational expressions with the same denominator. Notice that, there's the same denominator. And we can now add or subtract these rational expressions.